Good morning. Hey, what's up, guys? My name is Cherno. It's about 7:30 a.m. Just woken up. Today's going to be the first day of Hazel 2D. So I'm going to be working on the 2D rendering side of Hazel. I thought that I would record kind of my day, I guess, as like a bit of a vlog, just to show you guys how the day goes and how Hazel 2D goes. So this is going to be kind of like a day in the life. Let me know what you guys think of this kind of video. Hopefully you'll enjoy it. Never really done anything like this before. So right now, my wife Anya is home this morning, so we're gonna go and make some coffee and some breakfast, and then after that, I think she's gotta go off to work and do like some fire training or something, and I'm gonna get right into Hazel 2D. So that's pretty much how the day's gonna go. I don't know what else is gonna happen. Should be pretty good. But right now, let's go make some coffee. You know, just talking about coffee is waking me up. So let's just go ahead and make some coffee. Okay, so now that I've had breakfast, we can finally get into some work. So I've already planned a pretty good deal of 2D on the whiteboard here that's behind you guys. Specifically, I just wanted to go over what it is that I wanted to achieve with 2D. It's always good to set goals and kind of, I guess, define a certain level of features, a certain feature set that we want to kind of include in 2D. I think it's really good to have some kind of goal in mind, especially when you're working on something like this, because I think that it kind of gets you excited and it's nice to just kind of aim high and then hopefully get to as high as you are aiming to get to. But don't get me wrong, I definitely don't want to spend too much time planning this. I think that it's very easy to fall into the trap of just planning without actually getting anything done. 2D is something that I have done before, so there's no reason for me not to kind of try and jam it in. But the thing is, this is 2D for Hazel, right? And Hazel is kind of like, the Hazel engine is kind of like my baby. It's like the big kind of software project that I'm working on. It's my main kind of software project. I don't want to just jam in any kind of 2D solution. I want this to actually be good. So I definitely don't want to just kind of blindly start typing code and then, make some bad decisions down the road. So I still have taken a bit of time to think about it. I think that with software in general, though, it's obviously way better to just iterate over it rather than just sit down and plan this amazing thing and then pull it off and then everything's perfect, because it usually doesn't work out that way. It's usually a lot better to actually start with something, right? Plan a little bit, start typing the code, start making stuff work, and then halfway through realize, okay, we've got something up and running, but it's a bit too slow, right? It's just, I'm able to like display like, I don't know, 100,000 sprites. That's not good enough. I want more, right? And then on that kind of note, you kind of go back, you retrace your steps, you come up with a better solution, you figure out why it's slow in the first place, you iterate over it. Because a lot of the time I found is that, you want to go for this incredible solution, but you don't really need it. It's kind of like those people who say that premature optimization is the root of all evil, which is something that I don't really think that it's like the root of all evil. I don't think it's that bad. I think that optimization is good at any level. But to an extent, I guess they're right in the sense that you sometimes end up over-engineering solutions. You sometimes end up creating stuff that you don't actually need, right? And that can be a problem in itself, because apart from making something that's just way too fast, for example, I know it sounds crazy. It's like, how can something be way too fast? Sure, but if you've spent all that engineering time on this, right, is it even that important? Is it even worth all of your time? Those are really good questions. I really hate people who just are all talk, who just talk the talk, but they don't walk the walk, right? All talk, no walk. I don't like that. Stop talking about what you're going to do and actually start doing it. That's pretty much how I'm going to handle Hazel 2D. I'm not going to spend too much time talking about how great it's going to be and how I'm going to do all this. I'm just going to set a very concise goal, right? 1 million particles. I want 1 million 2D sprites on the screen at one time. That's going to be my goal. Just throwing that number out there. 1 million seems like a lot. I know it's possible. Let's go for 1 million particles. That's going to be our goal. And I'm just going to get to work and make it happen. So the first thing I want to do is start with the public Hazel repository. I gave this a bit of thought and I decided that I don't want to start with Hazel Dev, because that is pretty much a 3D renderer. There's no 2D there at all. And so for me to kind of start ripping out, the 3D renderer and like abstracting it properly so that we can have both 2D and 3D, that's going to be a lot of wasted time. I'm literally going to go over to github.com/thecherno/Hazel, clone that repository and start from there as it is today. In fact, if we just take a look at it, I mean, it doesn't even have a README file. Like, it's just got Hazel. I think today is going to be a pretty good maintenance opportunity, we'll say, as well, because what I'm going to do here is I'm going to make a proper README, I think, for Hazel, so that people have been leaving comments for so long being like, I can't clone Hazel, it doesn't compile for me for some reason, and it's usually because they're not recursively cloning all of the submodules as well. I think a README file would really benefit from that. So we're going to go ahead and, apart from getting 2D, just like, I want some sprites on the screen by the end of today. That's how we're doing this. We're actually going to get stuff done today. Apart from that, I'm also going to fix up this repository, I think. So anyway, enough talking. Hazel 2D, let's do this. Okay, so it's been a couple hours and I really got into the idea of making a good README page for Hazel, some kind of like cover page that just tells everyone how to actually download the engine and use it, because I know that for like literally as long as it's existed, people have had issues with that, so that I thought I'd be super productive and get that done. But, what are you gonna put here, right? Like, you need to have some kind of logo. So I decided to spend a while coming up with some kind of logo for Hazel, and this is kind of what I came up with. It's really clean, it's really simple. Here it is on white and here it is on black. In terms of like my inspiration for this, really, I just wanted something really, really clean. I looked at the other kind of engine logos out there, like Unreal, Unity, and Frostbite. Probably my favorite one out of those was definitely Unreal, and you can see that basically what they've got is just like the letter U in kind of a stylized way here that almost depicts some kind of role-playing game or something like that when you look at it. They had a circle around it, which I also actually tried, but that just looks like a helipad, and also I just don't like it at all. So I kind of got rid of the circle. Didn't want to go with that and just ended up with something really clean like this. So let me know what you guys think of this logo for Hazel. Since we're rendering 2D, it's also a good kind of candidate for a texture just to put into the engine to have. And yeah, I mean, I really like it, and it's only a couple hours of work, but I think so far that this might be the official Hazel logo. Merch coming soon. So right about now it's looking like lunchtime, and with Anya coming home soon from a little work thing, I thought that I'd try and make something nice for us. Lately I've been really getting into making Japanese food. Really since our honeymoon in Japan, we've been just even more into Japanese food than we were before. A few days ago I made a really nice curry katsu, and today I thought that I'd give the kind of onion and egg sauce, just really a regular katsudon, a shot. I find that it's really nice to take a break from kind of just programming and sitting at your desk and just to go out and just try and make something new in the kitchen. Cooking with Cherno really is a real thing. Definitely some things I'm going to change for next time I make this, but otherwise I think it turned out pretty okay for a first attempt. And of course, after this delicious lunch, it's time to get back to work on Hazel 2D. I'm kind of like, about working in the afternoons. Mornings and evenings for me are a lot more productive, I think. Usually in the afternoon I like to go to the gym or just go outside and do something like that, because I find that if I sit at my desk, I'll just kind of start procrastinating, watching YouTube videos, not really spending time working. But today I thought that I'd stick it out because I needed something to show you guys, of course, so thanks. So I just want to take a moment to thank our sponsors for this video, PBS Studio. For those of you who don't know, PBS Studio is something called a static analyzer, and if you're not using one of these, well, you really should. What a static analyzer does is it looks through the source code that you've written, and it just looks for mistakes or things that you've written that it doesn't think that you meant to write. So it's quite common, for example, when you copy and paste code, that you accidentally forget to change the names of certain variables. And then later down the road, of course, everything will compile, everything will run, but you'll run into issues that might not be 100% apparent. And I'm using PBS Studio right now just as an extension for Visual Studio, and as I'm writing all of this Hazel 2D code, it's just continually checking it for any mistakes that I may have written. It's almost like a spell checker for C++. And it also works with C, Java, C#, really with anything that you're probably building, PBS Studio will just check it for you. It's kind of like an automated code review. Instead of getting someone to go ahead and review your work, you can just let PBS Studio do it. And in fact, it also points out things that you could optimize to make your code run faster and tells you how to actually do that. So PBS Studio reached out to me around 2 weeks ago, and ever since then I've been using their product pretty much every day for every project that I've been working on. And right now, even for Hazel 2D, like, it's pointed out some pretty good stuff. So literally a real world issue from today. I had this weird problem where if I launched Hazel, the camera basically wouldn't render anything at all. Like, you wouldn't see anything until you resized the window. And that was odd because I was pretty sure that my logic for resizing the window was identical to what it was during construction. I mean, you can see here that I'm just making a new orthographic camera. I've got my aspect ratio, I've got my camera zoom. The exact same code is being called here, right? So I've got my camera, I've got my aspect ratio, I've got my camera zoom. It's being constructed. If we look at them, they're both initialized. We have our camera zoom, we have our aspect ratio. What is the problem? Why is it not rendering anything until I resize? So I ran PBS Studio through all of this, and I noticed that whilst there were a lot of things here, there were two actual errors that popped up here. The initialized class member M aspect ratio is used to initialize M camera member. Remember that members are initialized in the order of their declarations inside a class. I love that it actually explains what it is, because I looked at this and I was like, what do you mean the uninitialized class member aspect ratio is used to initialize camera? I mean, sure, it's not initialized here, but aspect ratio definitely is initialized. And it was only after I actually read that members are initialized in the order of their declarations that I remembered, well, of course this isn't working, because camera is being initialized up here, but then the camera zoom and aspect ratio is being initialized here, which means that since everything gets initialized in the order that it is declared, this camera initializer, which is located in the constructor, is using aspect ratio and camera zoom as they appear during this line of code, basically, which means that they're not initialized at all. And therefore, I was just doing uninitialized memory. I was just accessing uninitialized memory and nothing was working. So by simply moving the camera zoom and the camera aspect ratio up before I actually initialize the camera, if we take a look at what that looks like, of course, it will be completely fixed. We're no longer accessing uninitialized memory, and as you can see, everything is working as it should be immediately. There are also a bunch of really cool articles on the PBS Studio website that just kind kind of explain all the different things that PBS Studio can detect and just real world examples. I'll link one below in case you guys want to take a look. I found it pretty interesting. So PBS Studio have been nice enough to give you guys a 30-day free trial instead of the usual 7. All you have to do is go to the link in the description of this video and just enter the promo code Cherno. Go ahead and do that now. There's no reason not to try it out. Run it through your projects. I'm super interested to see all the cool stuff that it will pick up because, as I mentioned, I've just been using it for about 2 weeks. I'm still quite new to it, and I'm definitely interested to see what it can do for your source code. And of course, huge thanks to PBS Studio for sponsoring this video. It's awesome companies like those that make it possible for me to be doing this full time. So anyway, let's get back to Hazel 2D. Okay, so now we are at the end of the day. It's now the evening of what was a pretty long and quite productive day, actually. I think that making this day in the life kind of thing actually forced me to do work because, of course, I couldn't just go and lay on the couch and just watch videos and do nothing at all, because I had to, film time lapses of me actually working. That also kept me on task. So it's actually quite interesting that documenting your progress through like, I guess, through video form really does actually benefit you, which is why I tell people who want to make YouTube videos but get no views to just still do it, because it's actually quite useful for you as well. Not to mention you, of course, improve your skills. But anyway, back to this. So basically what I did is exactly kind of what I set out to do, which was just to try and render a whole bunch of sprites at once. What I did was I created this sandbox 2D layer, which is kind of the same thing as as the regular kind of sandbox layer that you see in the Game Engine series right now, as of like when this video went up. But basically what I did was refactored it a little bit, changed it, rewrote the whole thing really to be a specific 2D sandbox, so to test my 2D rendering, which was kind of the point of it. If you look at the other stuff that is in Sandbox, that's kind of how it's supposed to work. We have Sandbox app, and what that does, that actually has this example layer, which is what we have in the Game Engine series. But instead of that, what we have here is a Sandbox 2D layer that I'm pushing. So instead of this example layer, I'm not pushing that at all, because if I did, that would of course render and also update, and I don't want those two layers interfering because I haven't really set them up to play nice with each other. So I just have my Sandbox 2D layer, and then from that Sandbox 2D layer, what that has is just a whole bunch of different like shaders. I've stripped most of the stuff out, probably haven't cleaned it up exactly, but you can see I've added some events for like mouse scroll, window resize, stuff like that to get that stuff to work. And I also added a whole bunch of debugging really, so that I could actually test this 2D rendering stuff. So I've got like stats for rendering and all of this kind of fun stuff like that. And I'm actually just, I think, creating the 2D renderer right here in the sandbox layer for now. But basically what I've got is a pretty simple clean API that I've written. I created this whole renderer 2D thing, by the way. I don't want to take you guys through the code too much because eventually that'll make it into videos, not to mention this will probably change. If you're really interested in the technical aspects behind this, I can maybe make a video. I'll definitely make one for patrons if they want as well. But I'm just not really the intention of this video, I think, to show all the technical details. It's more to just give you guys an overview of what I've done. So we do have a whole bunch of code that I've written here for the 2D renderer, because it's a batch renderer essentially. So what you do is you basically give commands like draw quad, and then what that will do, and you can see that coming in through Sandbox 2D, what that will do over here is basically grab all the data that you're submitting, which is stuff like the position of the quad that you're drawing, the size of the quad that you're drawing, and then the color of the quad that you're drawing. I'm just kind of using a function here to define the color just so that we get basically a gradient across where that quad is positioned essentially. And then I'm drawing two other quads. Basically, this is all it really takes to draw a quad. And then what that actually does is it pushes vertices into a vertex buffer dynamically, and then we upload that vertex buffer to the GPU every frame. It's very simple. It's basically a simple batch renderer, where instead of course rendering everything one by one and then having a billion draw calls, what you end up with is just reducing the kind of draw calls, and then by batching things together, which results in a much faster performance when you're rendering a lot of geometry like this. So I did a whole bunch of IMGUI stuff as well so that I could actually see the performance of this in real time. And then as I mentioned, just a whole bunch of stuff. So let's just take a look at what we actually end up with. So this is what Hazel looks like right now with the Sandbox 2D or the the Sandbox 2D layer pushed onto the layer stack. So this is what we have. This is the application. I'll kind of make it a little bit bigger so you guys can see. Just taking you through this a little bit. Basically, we have this kind of world, I guess, that's being generated. It's a whole bunch of sprites, and you can see they're being submitted just through these for loops that we have here. And this is all kind of dynamically resizable. And there are some statistics here as well. So we have 2 draw calls at the moment. Not sure why we have 2. Oh, okay. Well, yeah, the max quads per draw is 10,000. So that's how many quads we can batch together, how many little rectangles we can batch together into a single draw. We have 10,002. That would be why. If we change this to 10,002, that's 1,000. 10,002, you can see that we have 1 draw call now, of course, because everything's being batched together into a single draw. And then number of sprites is how many sprites we have. So you can basically make this larger or smaller to see what the impact is like for performance. And you can see that that will of course reflect over here, which is the number of quads that we're actually drawing. Now 137, you might be like, number of sprites, 137, why is that the case? It's basically one, it's one axis, 137. So what happens is you, of course, end up with 137 times 137 or 137 squared, because both the for loop, both the y and the x inside the nested for loop will actually be affected by that number of sprites. That's how many sprites you get in one axis. So the x-axis will have 137, y-axis also 137, and you get this whole grid of 137 squared sprites plus 2 for these 2 that I just decided to draw for some reason. Anyway, that's what we end up with. And my primary investigation here was, of course, to see if I could even render 1,000,000 sprites using this strategy, because this is quite simple. And I wasn't really sure if it would be enough, because like generating vertices, generating geometry on the fly using something like a geometry shader, I imagine would perform better. And it's probably something that I'll do, but I just wanted to see what I could get with this as it was. And I do have a 1080 Ti GPU and a very good, it's like an AMD Threadripper 1950X, I think, the 16 core Threadripper from like a year or 2 ago. So very beefy machine, but I'm able to get pretty good performance. So it's hovering around a millisecond here, but if I bump the number of sprites quite high, you can see that we're at about 5 milliseconds now, which I don't have a frame rate here, but that's obviously quite a lot of frames per second. 16 milliseconds is 60 frames per second, and 33 milliseconds is 30. So if I bump this basically all the way, let's just see what we get. So at about, I'm able to draw about 500,000, and this, keep in mind, this is with 10,002 max quads per draw. So it's splitting this up into 51 draw calls. So about 60 FPS we can get with 500,000 quads. So that's not bad, and you can see zooming out doesn't affect it too much. We're still at around 17 milliseconds here, so that's not too bad at all. There are some spikes, as you can see, but apart from that, it's looking not too bad at all, and it's quite interesting to look at. And then if we bring this up so that we cross 1,000,000 or we reach 1,000,000, you can see that's at about 34 milliseconds, so around 30 frames per second, which of course is not good enough to be like 60, and it's not good enough to probably render that many. And you can see some really interesting things start happening when you zoom in at certain levels, because of the way that it's trying to, well, I guess the pixels are kind of fighting each other, because there's not enough fidelity, of course. There's not enough resolution to display all of these grid lines, which is interesting. But there you go, right? And then, of course, if we just lower, instead of doing like 1,000,000, if we just go back to like 200 or something, which is 40,000, and now I have to find my world again. The other thing that I wanted to play with is to kind of just find out, I guess, how many quads you could have in a draw. So what kind of the efficient, well, not really efficient, but what like an optimal amount to have would be. So in other words, at which point is it better to have more draw calls rather than having a huge batch of sprites together? And it's interesting to kind of play around with that, because you can see if I reduce the max quads per draw, and we kind of end up with more draws as I do that, it's interesting to kind of just watch the performance and see how it goes. So you can see 4 milliseconds we get with 50 quads per draw, because that's 785 draws. That's a lot. Whereas if I drag this up, you can see that the performance is a lot faster. Doesn't really change too much, but if I drag it really down, to like 0, you can see that performance it takes 145 milliseconds, which actually isn't too bad for 40,000 draw cores, I think, but probably because of my hardware, but that's obviously terrible. And then as we kind of ease that up, even doing something like 1,200 draws is relatively okay. We get about 5 milliseconds, but that of course means that as I raise this up, using that kind of a batch of that size, I hit 16 milliseconds pretty quickly. Whereas if I just make this a little bit bigger, it goes down to 5 milliseconds. So interesting to play around with this. It doesn't really look like anything. It doesn't really look like anything above 10,000 certainly would give you any performance increase. So like, I don't know, if we're struggling here because we're hitting, 24 milliseconds, increasing that doesn't necessarily seem to. You can see the draws are going down, but we're still at about 26 milliseconds because we must be hitting a brick wall somewhere else, probably just with the amount of data that we have to actually process in the vertex shader and actually render and the pixel shader. So that's basically, well, no, I mean, to rephrase that, I definitely don't think it's like fill rate or anything like that that's bottlenecking this. It's probably just the fact that there is a lot of data to get through. Now, if you wanted to view it more, if you wanted to view everything at once, then we would have to switch to some other way of rendering completely. But of course, in most situations, if you're not looking at a million quads at once, or in this case, what are we at, 700,000 quads at once, then you could of course just cull everything. There's no culling happening at all here, no CPU side culling whatsoever. Every quad is being submitted. 702,000 quads are in that vertex buffer. That's what OpenGL sees, that's what your GPU sees. So because of that, of course, by just culling everything to the camera view, instantly you'd be at like pretty much at probably 1 or 2 milliseconds for no matter how many sprites you have. But of course, if you want them all in view, which could be useful for like a particle system or something in the future, then in that case, yeah, you would have to come up with a better way to render that. So that's basically what I've done for today. Next time I do look at Hazel 2D, which might be next week, I definitely want to add textures and stuff like that. I imagine that will have quite a decent impact on performance as well, but we'll see. And then that will of course affect how we can batch things together, because well, we can certainly have probably up to 32 textures in a single draw, but because this would have at least 32 texture slots, I imagine, but mobile hardware might not. So that would kind of come into the land of, we need to know what platform we're making this for. But anyway, that is basically what I've achieved today. So I hope you guys enjoyed this little video. I'd never done anything like this before, as I said, so I'm curious to see what your guys' feedback is. If you enjoyed this, if you want to see more of this kind of stuff in the future, it was definitely very fun to make. Yeah, let me know what you think in the comments below, and I will see you guys next time. Goodbye.